All right, in this podcast, we're going to talk about the salt bridge, which is in an electrochemical cell. All right, so I'm going to focus on the galvanic cell at this particular point in time. We have a copper zinc galvanic cell. If you have pulled the reduction potentials for copper and zinc, you realize that copper is going to be reduced and zinc is going to be oxidized. Okay, so we have electrons flowing this way, going down here. All the copper 2 ions in solution are gaining electrons, plating onto the copper electrode. Copper electrode is increasing in mass. All right, our zinc electrode is actually depleting as it loses electrons. It is producing more Zn2 pluses in the solution. So at the very beginning, in the copper sulfate and the zinc sulfate, we had equivalent amounts of copper and of zinc. However, as this reaction continues to run, all the copper 2 pluses are gaining electrons and are leaving solution. So you're basically left with an excess of SO4s in solution. So you got way too many SO4s over here. All right, now over here, we had equivalent amounts of zinc and sulfate. And as time goes on, the zinc electrode is losing its electrons and it is being dissolved in solution as Zn2 plus. So over time, you just keep getting more and more and more of the zinc electrode. So what's happening is this particular side, the side that's being oxidized, it's got too many positives going on. It's giving away so many electrons that now the solution itself has become too positive. On this side, because we're losing all our positives, they are gaining electrons and adding to the electrode. We have too many negatives over here in this solution. Okay, so what this is doing is it's slowing down our reaction because our concentrations are getting out of whack. And because our reaction is slowing down, we're not getting near the amount of volts from it that we should be getting from it. This leads us to the whole idea of the salt bridge. So the salt bridge is the U-shaped tube that is connecting your two cells. It contains a solution of a gel that has soluble ions in it. Often, sodium, sulfate, and nitrate are used. The key point here is you do not want these ions that are in your salt bridge to play a role in the redox reaction, and you do not want them to be able to react with any of the ions that you already have in solution and be able to form a precipitate or a solid, okay, because that's just going to throw a whole big kink in there. All right, so ions from the salt bridge, they are going to travel through the salt bridge towards the half cells in order to keep our half cells neutral. If we do not keep our half cells neutral, then eventually our reaction is going to stop. Just like we talked previously, it's going to slow down, slow down, slow down, slow down. So the salt bridge keeps that from occurring. Okay, so in this particular picture, understand that my two electrodes have been swapped for some reason. Okay, so I've got my zinc electrode over here. Remember, it is getting smaller because it keeps putting all these Zn2 pluses in solution, so we end up with an excess amount of positives. And then over here, my copper is gaining electrons, so it keeps removing the 2 pluses. So you end up with an excess amount of sulfate, so this side has got too many negatives in it. All right, now up here in my salt bridge in this particular example is composed of Na plus and SO4 2 minus. Okay, so my SO4 2 minuses, which are my anions, they are going to migrate towards my anode, or the part of my solution that is getting overcome with these positives over here. Okay, so it's going to come over here and help to neutralize all of these positive Zn2 pluses that keep getting pushed into solution. All right, conversely, are my cations. My cations are my sodiums. So my sodiums are going to go towards my cathode, because my cathode, as you remember, all of the copper 2 pluses are being removed from solution. You have all these excess SO4 2 minuses, and so the sodium migrates this way to kind of neutralize all of these SO4 2 minuses. Okay, so anions go towards the anode, and the cations go towards the cathode. All right, so little thinking question. Would it be better to use Na2SO4 or BaSO4 in the salt bridge? Remember, one of the rules of the ions in the salt bridge is that they need to be soluble, they need to not participate in the reaction, and they need to not make it precipitate, which means they are soluble. Okay, BaSO4, this is actually a solid, which has a KSP value, so it's one of our slightly soluble salts, has an equilibrium, so very little of the BaSO4 actually dissolves in solution. However, Na, this guy is always soluble, so because of that, he is always going to be split up, and then my SO4 will also make another component of it and be split up. So these guys, NaSO4, do not form a precipitate. BaSO4 does.